All right, number 7, number 8, 9, and 10, we are finding the 6 trig functions of the angle we are given. None of these angles are between 0 and 2 pi, so we're going to have to start by figuring out where these angles are first. Since I have negative 3 pi over 4, I'm going to add 2 pi, and I'm going to do that in fourths. So 2 pi in fourth is 8 pi over 4. So negative 3 pi over 4, negative 3 plus 8 is 5. So negative 3 pi over 4 is the same angle at the same spot on our unit circle as 5 pi over 4. I like to draw a picture of that as well. 5 pi over 4, 1, 2, 3, 4, 5. 5 pi over 4 is in the middle of quadrant 3. And really, the more work you can do in the beginning, the easier things are. There, cosine is positive. Cosine is negative. Sine is negative. Tangent and cotangent are going to be positive. So whatever order you like to do these in, just make sure you match the order I give you on the test. Sine of 5 pi over 4, cosine of 5 pi over 4, and tangent. I'm going to find those first. And that, of course, is the same as negative 3 pi over 4. That's what we're finding. So sine at all of our fourths is radical 2 over 2, but we talked about how it's negative in quadrant 3. Cosine at all of our pi over 4s is also radical 2 over 2, but we're negative in 5 pi over 4. Tangent is sine divided by cosine, so that's why I like this order, because for tangent I can just look above and kind of imagine that divide by there. Anything divided by itself is 1. And so here you have negative radical 2 over 2 divided by negative radical 2 over 2. The negatives cancel each other. Anything divided by itself is 1. And now we're going to flip those values. I'm writing 5 pi over 4, but you can absolutely write negative 3 pi over 4 if you would like as well. Cosecant of 5 pi over 4, if we flip negative radical 2 over 2 over 2, negative radical 2 over 2. Stuff like this. So let's do a little work here. Rationalize. Radical 2 times radical 2 is 2. There are 2's cancel, so that whole mess is actually just equal to negative radical 2. That helps us with secant, which is the reciprocal of cosine. The same, negative radical 2. And cotangent is the reciprocal of tangent. When we flip 1 or 1 over 1, we get 1 over 1. So those are your 6, and they're kind of messy. But messy is okay as long as it's precise and correct. Awesome. All right, on to 3 pi. Again, 3 pi is too big, not on our unit circle. I'm going to subtract 2 pi to get it onto the unit circle. Don't have to worry about common denominators here. We can just subtract 2 pi. And so we're doing all 6 trig ratios of pi. And again, nice to draw a picture. Cosine is negative 1, sine is 0. Plot that ordered pair for yourself. Again, I'm going to do sine, cosine, and tangent first, and then I'll do the reciprocals. So sine at pi is 0. Cosine at pi is negative 1. And tangent is sine over cosine. So I'm going to write 0 over negative 1 to make sure that I know that that is 0. Now, when we flip these, you do need to imagine any of your zeros over 1. And when you flip to do the reciprocal, flip the whole fraction. So cosecant at pi is 1 over 0. And 1 over 0 is not 0, it's undefined. So that's important. If you were to write 0 there, or if you were to just write nothing, you wouldn't get credit for it. You need to write undefined. Secant at pi, if we flip -1, we get -1. Remember, all of our whole numbers are, you can imagine them over 1. And cotangent at pi, we're going to flip either 0 over -1 or 0 over 1. Cotangent is cosine over sine, and so cotangent is undefined. It's really easy to get in the habit of like, oh, if I have 1, I can flip that and get 1. If I have 0, can I flip that and get 0? You can't, so you have to be careful about that. All right, so that was 7 and 8.